All right, hello and welcome everybody. So this is on the Tract A portion of the site. So ideally it's meant for those who have more of a design background or are trying to go along aspects of designing plans. So I know we're probably going to have a lot of designers in here. We may also have some contractors as well, which I think is absolutely great. Marlena mentioned earlier, and I just kind of want to reiterate it to you, we have short sessions, so this is just a quick hit on this topic. So I'm going to hopefully leave you guys with questions, but not confusion. Okay, so that's my goal for this session. And I'm hoping that we can get through the whole slideshow in this time. I come from Colorado, but I've done work throughout the nation, and actually I've been to another country as well that is very arid and tropical. So I've been able to be exposed to a number of different climates and the conditions and the issues that are faced by those different areas of the world. And it's amazing how different the plans need to be for some place that is arid or semi-arid versus some place that is more humid or tropical in nature. The amount of rainfall that you can get can be a lot. In Colorado, we get roughly 14 inches of annual precipitation, but a lot of that comes in snowmelt. Okay? So we have a different world that we deal with there versus here. You guys are dealing with obviously just straight precipitation, but you're also dealing with more continual storms throughout the year. You have a wetter time during the year and a drier time, but you still get the rainfall throughout the year. And depending on which side of the islands you're on, you may get a lot more rain versus a lot less. So trying to make the plans fit what you want is a challenge. And I recognize that. So what we're going to talk about today, and I know my boss actually, Jerry, is going to take the rest of the A track, so if that's what you're looking at, you're going to see his mug for the rest of the day, and you're going to listen to him, which he has a lot of good things he's talking about. So I'm going to start off talking about just sediment and erosion control plans, because I think at times there can be a confusion as to what is a SWIP, what is a narrative, what are the plans, and how they relate. So aren't sediment erosion control plans the same as a SWIP? And I call them sediment erosion control plans. I know a lot of places refer to them as erosion and sediment control plans. I have to be ornery and just be a little bit different in how I look at it. So when I talk about S&EC plans, I'm talking about the erosion and sediment control plans. But aren't they the same as a SWIP? Well, the answer is actually no. A SWIP is actually made up of a couple different components, one of them being the drawings themselves. The other aspect is the narrative. Both of them are very important to the actual project, but to me, they cover different aspects. The information be the same, it's just presented differently. The part that I look at the most is the drawings. To me, that's what the contractor is going to be following on the day-to-day basis. They're going to pull that plan out, and that's what they're going to look at. They're going to be putting the BMPs in as illustrated, as described, per the drawings, with references to the narrative as well. So we're going to just focus on the plans. One of the tracks later today will talk about, I believe, the narrative. So the importance of the drawings. They need to be developed by a qualified designer. Whether or not that designer is a PE, a CPES, which is a certified professional in erosion and sediment control, or some other aspect, it doesn't matter, but they need to be qualified. And when I say qualified, what do I mean? I mean it's a professional who understands the world of sediment and erosion control and everything it entails. They have to possess some construction site experience. So if you're a designer and you've never been out on a construction site, I suggest you get out there. I suggest you get out there when it's raining and after it rains. Right there, you will gain a lot of knowledge as to how BMPs work and, more importantly, how BMPs do not work. Okay? As a designer, you need to have that knowledge. And also, you need to be able to coordinate with contractors and regulatory agencies. So the drawings must reflect the project site conditions. If you look at the HAR and everything, it gives you guidance as to what should be included on what they call the site map or the drawings itself. But it incorporates hydrology, soil conditions, vegetation. Those are just a couple items of what should be included and should be known about to be able to do a good set of drawings. We need to know which way water is going to flow, where water comes in, where water leaves. I need to be able to take a look at a set of drawings to be able to very quickly know how that water flows across that site. Okay. And it must be practical and cost-effective. I know, the cost-effective part is the big one as well, but it has to be practical, and it has to be effective. So when we look at the drawings, we know that they have to illustrate effective and timely methods for the installation of sediment control BMPs as well as the erosion control BMPs. So how we are going to be controlling the sediment, minimizing the discharge of it during the construction phase, but also the stabilization aspects of the site. So this is kind of, I look at this and say, this is actually a great photograph because it shows a lot going on it. And this is what we're trying to strive for is BMPs that are working in conjunction with the actual project itself. I mean, you can see they're working up here on the roadway, but they've already started stabilization. That's kind of the goal when I look to putting plans together, is trying to get that combination of sediment control with the erosion control aspects being done during the construction process. But our task as designers, when we're given these set of plans, this project, our goal is to go from basically existing conditions to a final product. And we have to do it in a way that's accountable and effective. So it's not the last-ditch effort, oh my gosh, we got to get this submitted to the regulatory people next week, quick, put some plans together. We need to put some thought and some effort into developing the plans themselves. So what are effective sediment and erosion control drawings? Well, obviously, they're going to be plans that meet local criteria and specification. Maybe there are also plans that meet a federal level as well. But at minimum, we need to be meeting what those local requirements are, whether here it's an HAR or whether or not you have something specific due to the type of land you are on. Absolutely, we need to meet those criteria. That's what gives us the guidance to be able to put together the plans themselves. The plans that meet requirements of a checklist. I see more and more in the years the use of checklists by regulatory agencies saying, I have a checklist, this is what you have to have on your set of plans. To me, the checklist is the starting point. That's the minimum that we should be seeing on the plans. We need to give it the thought and the effort and say, should I be going beyond what's just required on a checklist? Plans that are approved by a regulatory agency, ideally, yes. We need to make sure that we have the approval, that they recognize that the plans do meet those local criteria and specifications as well. But this one, to me, this last one, is the biggest and most important part of putting together a set of plans. It has to be something that can be implemented by the contractor. If the contractor can't figure out what the heck your plan is trying to say, what do you think the contractor's going to do? Just kind of wad it up, throw it over his shoulder, and then try and do what he thinks is going to work and work best. So why put the time, the effort into putting together a design that is basically going to be negated or completely amended by a contractor? A lot of time and effort's been put into it. That's waste, and that's my opinion, okay? So we need effective plans that require accountability. All right, I'm going to go through just a very quick review of an existing plan that was actually approved. It was done by a designer, and it was actually approved by a local regulating entity. And I just want to point out some of the aspects that I noticed on this plan that bothered me, and it bothered me a lot. Okay? So the plan that we're going to look at, it's a roadway project, and the parts of the plan I'm going to look at, we're not looking at the whole thing, we're just looking at one little page, is the plan and profile. And what I'm actually going to look at on here is I'm going to take the profile, because to me that was a key aspect in understanding what was going on this project. And then I'm going to take a look at what they call the erosion control plan. And you notice that the word erosion is in quotes. I'm going to cover that as part of the review. And this is what the erosion control plan looked like. And I know all the wording on the stuff is really small. Don't worry, I'll go over it with you, what those little boxes entail. So this is what the erosion control plan actually looked like. All right? Not a lot there, in all honesty. So I'm going to take those two drawings, and like I said, I'm going to actually use the profile to go in conjunction with the plan on the erosion control aspect of here. The first thing that I noticed on this plan was, where are the contours? How can you tell where water is going to go if you don't have contours on your plan? You don't. It's a lot more difficult process to try and figure it out. And it's not just contours of where the water is going on the project, but like I mentioned just a little bit ago, where water's coming into the project, where your water's leaving the project, how much water is coming into your project. Is it a little tiny bit? Is it a lot? Is it concentrated? Is it sheet flows? These are the things I want to know, and this drawing doesn't tell me anything. okay? All right, hence why I pulled out the profile. That's what I needed to at least give me some guidance. So I laid it down below the plan view, and I kind of broke it up into a couple different aspects here because this kind of helped me determine where the runoff was going. But the thing that I noticed as well on here was, well, okay, we're missing contours, but also I kind of can guesstimate, where the bottom of the fill slopes are based on where a certain BMP is actually installed. And it's actually silt fence, which I'll point out to you here in a minute. So I can guesstimate where the toe slopes might be. I can't tell you where the top of cuts are. Do I have a 150 feet cut? Do I have a 10-foot cut? That's going to impact the type of BMP I use, the type of sediment controls I'm looking at, the type of erosion controls I want to look at. So right there, I'm scratching my head and saying, I have no knowledge of how much material, how many cuts, the slope length, the size that I'm going to be dealing with, the steepness of it, okay? So that was one of the items that I noticed. But you can see here how much fill they're doing. And remember, your profile is based on just right down the center line of the road. So this tells me what's happening at the center line, but not a lot of what's happening outside of it. So what happens to road runoff during and after construction? Obviously something I want to know. I actually would like to know historically where runoff goes. But from this drawing, I can kind of figure out where runoff is going during construction. And after I scratched my head on it a little bit and said, okay, well, the profile tells me runoff's going to go probably from the left to the right. At least I can get that much out of it. But how does it correspond with culverts and diversion structures on this? Well, it took a little bit of doing, and I finally figured out that the roadway flows are actually being diverted off the sides of the road by some diversion structures. And so it diverts it off to the bottom and to the top sides of the road here in a number of different locations. Okay, that's not a bad idea because at least we're getting the runoff off the roadway at certain intervals, and it'll help in potentially reducing the erosion that can possibly occur on some of our slopes there. Okay, that's not a bad idea. I'd obviously want to go into more depth and find out exactly what these diversion structures are. Are they slope drains? Are they lined channel of some kind? I would like to know more about it. Next item, though, that I wanted to know was, that's just localized flows that I'm getting off the side of the road. Where does the long-term runoff go, the majority of the water that's coming down? Where are we having our culverts? And this one made me laugh a little bit, and it was just because of the lay of the land, I guess. I'm not sure what the lay of the land looks like, but the way the runoff goes, and it's a little hard to see, is it comes down. You can see these pathways. I'll step back here. You see these darker hatched areas? Those are going to be your roadside ditches. All right, so that tells me there's going to be some sort of swale down at the bottom that they're actually going to be protecting. And so when I started looking at it, this kind of corresponds to a cut here. There's a cut there as well, that the runoff actually comes down inside these ditches, crosses over from the south side of the road to the north side of the road, goes down that ditch, and then recrosses over back to the south side. Okay, that's an interesting way to do hydrology, but maybe that's what they actually had to do in this case. So obviously we have water jumping to both sides of the roadway here, and so it's something to be concerned with. And then this part here, the runoff goes from the left down towards the right and off the page onto a further part of the project itself. Okay, now I kind of have a feel for how some of the runoff's being hopefully controlled during construction, the construction aspect of it. But my question then is, though, and this is a question for you to think about when you're doing your plans, can discharges cause downstream problems? Absolutely. I hope your answer is yes to every time. These diversionary structures, and then the main culvert there means I'm having concentrated flows. How are those concentrated flows being treated when they get to the edge of the property? Do we just dump them onto somebody else's property and say, good luck with it? Is this going into a nearby creek? Is it part of a stream system? Is it going into a lake? Is it going into Farmer John's field immediately downstream? Things to be aware of, things to know is what's going on the downstream side and how construction runoff can potentially impact it. Because that may cause you to do other mitigation measures on the site to help control it. All right, now let's look at the BMPs. I just was talking a little bit about the hydrology, just barely touching upon it. Now let's actually take a look at more of the BMPs themselves, and this is where I'll look at some of these boxes right here. One of the items that we seem to use a lot of in this world is a very commonly used BMP is our silt fence barriers. It's not a bad BMP, it has its limitations. There are places to use it, places not to use it. So they have a little call out here and they indicate where all the silt fence is located, and there's a little tiny squiggly line on the upper part right there, and then you see the big long lines there. That was how I was able to kind of guesstimate where the toes of fill are, because on a highway project, typically we have a very narrow right-of-way, and so silt fence or some kind of barrier is normally like about 2 inches right off the bottom of the fill, just because we're so tight on our right-of-way. So that's why I guesstimated that the toe was along those areas where the silt fence was. Question for you guys. Do silt fence barriers represent erosion control? I see a couple heads shaking no. I'm glad you're shaking your head no. What is it? Sediment control. Absolutely. So right there, and this is to me, yes, a little nitpicking on the plan, but one of my goals as an instructor is to get our minds thinking in terms of the correct terminology. Okay? It's an erosion control plan. We're illustrating silt fence barriers. All right? Let's continue on. Let's now take a look here. I pointed out those spots where the concentrated flows come across the project. They're either off of diversions or from the culvert itself. Silt fence goes right in front of those areas. Do you think it's going to work out on the construction site when it rains? No, it's going to fail. All right, so right there, if I was a contractor, I would be calling out for amendments, saying I'm not going to be doing that, I'm not putting that silt fence across that culvert because that right there is increasing my maintenance cost. All right, so be aware of that when BMPs are being put on your plans, that you're not going to cause increased maintenance because of the placement of it. Okay? All right, next one. This kind of purpley pinkish color here are sediment logs or fiber logs, or they can be compost socks, but something along that type of avenue there. And if you look at how they're indicated, I just highlighted the places where they said that they're actually installed. They're being installed as check structures within those different little drainage swales themselves. Again, question for you. Do sediment logs represent erosion control? In most cases, no. They're typically going to, and I always put a caveat in here, depends on what time of the construction is actually, we're doing this at, we're installing these. But when we're talking about an actual fiber log or something that is going to degrade and is not going to be there permanently, it's going to be probably a sediment control barrier. So once again, we're dealing with sediment control aspects, not erosion control. So I'm scratching my head and asking myself, what was this designer thinking? Honestly, I think it was the designer didn't have the knowledge that they needed to be able to put one of these plants together. All right, lastly, erosion control blankets and turf reinforcement mats. We kind of grouped them together there just due to time constraints. But basically, they're placed in those same swales. Okay, I actually give them credit because they're actually utilizing a BMP that is good at controlling erosion. They're not just leaving these channels open and saying vegetation will take effect. They're actually putting a blanket of some kind in there to help reduce the erosion aspect of it. I give them that credit. Of course, my question to them was, especially if they're using TRMs, the fact that they're in a swale, did they do the proper calculations to determine the right blankets? Something that I would be checking to see if they have those calculations available. But that aside, that's a whole nother topic in it amongst itself. I'm just looking at the practicality of this. Okay, erosion control blankets within the swale there, not bad. However, my question is, why are sediment logs being installed on top of them? Something to think about. I know a lot of places we put blankets down and we put logs on top of them with the belief that those logs are going to help. It's a waste of time and a waste of money. All right, and again, another topic altogether. We can go into a lot of information on the reasons why, but be aware of it. Or I half joke, you know, the assumption is the sediment logs are being put on top of the blanket. I don't know, maybe they're being put under the blanket. I've seen it happen. Okay, kind of a chuckle factor there, but I have seen it happen. I don't know when the logs are being installed with reference to the blanket. Okay. And then when and how will those cut and fill slopes be stabilized? What type of material? I see nothing on here that illustrates it. So is this really an erosion control plan? We got just the erosion control blankets and TRMs that are the erosion control. The rest of them are all sediment control. All it is, like I said, I'm nitpicking it a little bit, but I want to get the right terminology out there. I would call this a sediment erosion control plan or erosion and sediment control plan. But that was just a quick touch upon an existing plan that was out there. It was approved. It was done by a professional designer approved by a regulatory agency, and those are the errors I saw on a very quick review. All right, now, what is necessary to design effective plans? Common sense. And a little, a bit of knowledge about the aspects of water, hydrology, and the BMPs themselves. But a lot of it is common sense. Water goes downhill. High amounts of water, higher amounts of velocities, higher amounts of erosion that could possibly occur. So this is just a quick suggestion on how I would put together a set of plans. It's something that contractors actually suggested to us many, many years ago, and we found that they were right. Instead of having one single sheet with everything on it, I'm going to break the drawing out into a minimum of 2, but more likely 3 to 4 drawings. If you look here, I have them broke out. Before grading drawings, during construction drawings. All of these are going to predominantly illustrate sediment control BMPs. We're trying to move land. We're trying to build something. We recognize doing erosion control during that aspect is going to be difficult. However, erosion control should be a part of it. When areas are temporarily left because work has ceased in that area, we need to be stabilizing them, even if it's temporary or long-term. But as you can see, sediment control BMPs, and then the fourth one, after grading and construction drawings, that's where I start illustrating the erosion control. I'm separating them. It makes it so much easier for the contractor to follow, okay? These drawings will reference the erosion control drawings, so that if temporary BMPs need to be put in to stabilize areas, absolutely, they reference that drawings for that information, but I'm separating them. Like I said, you could end up having a combination though, maybe only 2 drawings, maybe it's a before and during grading, and then an after grading. Combinations can occur. Okay, developing the final drawings. Designers, remember, ultimately the individuals that have to implement these drawings are the contractor. Get them approved, make sure you're meeting that criteria that is required, but then make sure the contractor can do it. I'm just going to throw these up there just to show you a little bit of flavor of how I would have broke out that one drawing I showed you at the very beginning saying we got to go from here to there. This is a small aspect of it. This is going to be your before and during grading. Once again, I've combined a couple drawings together, which is fine, but I'm keeping it simple. What you see here is predominantly sediment control. You have aspects of discharge points. I'm very much aware of them. There's a creek that goes along here, but I'm looking at what's happening during the preliminary grading phase of it. And I have notes, I have illustrations, I'm showing diversion berms, I'm showing silt fence, and I have a bunch of notes to correspond with it. This one is what I call the during grading and construction. So I have the before grading, I have the during grading, and as you can see now, I have the contours of the actual highway itself overlaid, where on this one, it's historic. I'm not at developed conditions yet, I'm just barely starting, so I have the historic contours. I want to know where that water is going historically. So that's what I deal with there. Water's going to go in these different avenues. It's going to be completely different once we start building it up, and I recognize that. So this drawing is kind of that intermediate drawing saying, okay, we're putting the fills in, we're doing the cuts, now how do I address the BMPs that need to be included there? Again, predominantly sediment control with notes over here to help out, and these will also direct you to the erosion control, which is the after grading construction. As you can see here, now, all of this is basically erosion control BMPs, seed and mulch, seed and erosion control blanket, TRM or erosion control blankets, all hatched in to illustrate how to stabilize that site. And then a bunch of notes here on the side as well. Just kind of a quick little touch upon how I would have broke that out. Like I said, this is just a quick course here. I can spend a whole afternoon just talking about these types of plans alone. But I wanted to give you kind of a little bit of a hint as to how I separated those plans out. So again, what does it take to develop plans? Common sense, but some additional knowledge as well. Okay?